Good afternoon.
Good afternoon.
ഓക്കെ, ഇന്ന് നമുക്ക് ബ്രേക്കിംഗ് സിസ്റ്റത്തിൻ്റെ കുറച്ച് വീഡിയോസ് കാണാം. ബാക്കിയുള്ളവരൊക്കെ ജോയിൻ ചെയ്യട്ടെ. ബേസിക് ആനിമേഷൻ ആണ്, അപ്പോൾ ഇതിന് ഓഡിയോ ഇല്ല.
Let's take a look at the components found in a typical drum brake system. We have the backplate assembly, the brake drum, the wheel, and the wheel nuts. First, we will take a look in more detail at the brake drum and backplate assembly. Brake drums are generally made of cast iron, which conducts heat well and is slow to wear. The drum rotates on the axle and wheels, providing the friction surface when the brakes are applied. Next, we have the backplate assembly. The backplate assembly contains all the components required to operate the drum brake. Let's explore each of these components in turn. The backplate remains stationary and provides a fixed base for the other components to attach. Next, we have the brake shoes. Brake shoes consist of a steel frame fitted with friction material or brake lining. This material is bonded or riveted to the outer face of the shoe frame. there is a wheel cylinder. The wheel cylinder is connected to the hydraulic system and contains pistons which are forced outwards by hydraulic pressure when the brake pedal is pressed. Shoe retaining springs pull the brake shoe down onto the backplate, keeping it in position. A tensioning spring is fitted to the shoes. When the brake pedal is released, hydraulic pressure is reduced, allowing the tensioning spring to withdraw the wheel cylinder pistons and pull the brake shoes away from the drum. This allows the wheel to rotate freely once more. Drum brakes use a self-adjusting mechanism. The adjuster takes up excessive clearance created as the friction material on the brake shoe wears, reducing the return movement of the shoe. This effectively brings the brake shoes closer to the drum and maintains a consistent pedal feel and braking response. Finally, the cable enters the drum through the backplate and connects to the brake shoe lever arm. Cable, electronic, and hydraulic systems are found in handbrakes, but in our example, cables are used to activate the rear brakes. When the handbrake is pulled upwards, the cable is tensioned, forcing the brake shoes out against the brake drum. A ratchet in the handbrake maintains this tension until the handbrake is released. And that's the basics of a drum brake system.
Let's see the principle behind the disc brake system. The brake system works based on the Pascal's law. The law states that pressure exerted anywhere in a contained incompressible fluid is distributed equally in all directions throughout the fluid. Let's make it simple. Consider two cylinders with pistons connected each other and filled with incompressible fluid. The mathematical relation is as follows. F1, applied force on left piston. F2, received force at right piston. A1 and A2 are surface areas of both pistons. P1 and P2 are pressure experienced by both pistons. Pressure can be stated as force experienced per area. So P1 equals F1 by A1, and P2 equals F2 by A2. According to Pascal's law, pressure on both pistons are equal, which gives us P1 equals P2. So, when force is applied to the left piston, the fluid will transmit the force to the right piston surface. But it will be a factor of the ratio of two piston surfaces. This concludes that, with a small force F1 at left piston, will give a higher force F2 at right piston, provided if A2 is greater than A1. With this, the left piston can act at the pedal side, and the right piston can act at the wheel side, transferring energy from pedal to the brakes. Now we know the theory, let's see how this works in real. Let's see the exploded view of a car wheel, and the parts involved. The wheel hub assembly, the disc brake rotor, the brake caliper assembly, the wheel, and the lug nuts. The wheel hub assembly holds the wheel and the disc rotor, and the bearing inside it allows their smooth rotation. The disc rotor is the part to which the brake pads squeeze against. This will create friction that retards the rotation of the wheel. The disc rotor produces a lot of heat due to this friction, and the drilled holes provides ventilation to remove this heat. The brake caliper assembly uses the hydraulic force from the brake pedal to squeeze the brake pads to the rotor surfaces, thus creating friction, and decelerates the wheel. The caliper assembly consists of the caliper bracket, slider pins, dust boots, inner brake pad, outer brake pad, caliper frame, and inside it, the piston. The caliper frame is having a banjo fitting, through which the fluid will reach till the piston. The pressurized fluid from the pedal side is capable of pushing the piston with great force. Also, the caliper frame is free to slide along the slider pins within the fixed extend. Now we know the parts, let's see how it works. When you apply the brake, the caliper will receive the high-pressure hydraulic fluid from the brake master cylinder. The fluid will push the piston, which makes the inner brake pad to squeeze against the disc rotor surface. As a result, the fluid's backward force will push the caliper frame along the slide pin, which makes the outer brake pad to squeeze against the other side of the disc rotor. Let's see one more time from the top view. The fluid pushes the piston, and the piston pushes the inner brake pad. Once the inner brake pad is pushed against the rotor, the fluid will push the caliper frame. The outer brake pad will now be pulled towards the other side of the disc rotor. This is how the disc brake system works on wheel side. In the next part, we will see what's a master cylinder, and how it transfers fluid to the caliper. Brake system works. In the last part, we saw the working principle at the wheel side. In this part, we will see how it works at the pedal side. The master cylinder is the main part here. It transfers the force on the pedal to the calipers. There is a push rod, outlet port, and a fluid reservoir tank. Let's see what's inside the master cylinder. There are inlet ports for the fluid to reach the cylinder, compensating ports, primary piston, secondary piston, retaining springs, and piston seals. Now, let's see how the master cylinder works. When you press the brake, the push rod pushes the primary piston, closing the first compensating port. This creates pressure in the cylinder, which pushes the secondary piston, and furtherly closing the second compensating port. Hence both pistons will push the fluid to their corresponding calipers. In case if the secondary piston fails to build up pressure, the primary piston can still develop pressure, with increased travel. And if the primary piston fails, the secondary piston will not receive any pressure to move. So the push rod at the end of the first piston can push secondary piston, which requires much force to be applied on the brake pedal. Even for a fully functional master cylinder, pushing the pistons through the brake pedal requires much force. So later on, another component named boosters were introduced. The brake booster comes between the pedal and the master cylinder, and utilizes the vacuum from the engine, assisting the brake pedal and makes it easier to apply brakes. Let's take a look inside the servo. It consists of a valve rod, dust boot, air filter, valve spring, diaphragm spring, vacuum check valve, hydraulic push rod. When you push the pedal, the valve rod opens the inlet valve, allowing air into the diaphragm front chamber through the filter. This air, along with the vacuum created by the engine in the diaphragm rear chamber, pulls the diaphragm, and furtherly pushing the push rod towards the master cylinder. Thus provides assistance, and reduce the effort in braking. And that's how an automotive braking system works. Thanks for watching, and stay tuned for more presentations from Auto Tech Labs.
A basic hydraulic braking system has two main sections, the brake assemblies at the wheels, and the hydraulic system that applies them. The most widely utilized brake systems at present are the foot-operated main brake when the vehicle is in motion, and manual-type parking brake when the vehicle is stationary. Some braking systems have all drum brakes, some have disc brakes from the front wheels and drum brakes on the rear, others have all disc brakes. A basic braking system has a brake pedal, a master cylinder to provide hydraulic pressure, brake lines and hoses to connect master cylinder to the wheel brake assemblies, and the wheel brake assemblies drum or disc that stop the wheels. The driver pushes the brake pedal, it applies force to the piston in the master cylinder, the piston applies pressure to the fluid in the cylinder, the lines transfer the pressure to the wheel cylinders, and the wheel cylinders at the wheel assemblies apply the brakes. On modern vehicles this basic system has some refinements such as a power booster. This helps the driver apply the brakes. A lever is a rigid bar pivoted around a fulcrum, used to transfer a force to a load. Levers can be used to increase force, increase travel, or change the direction of movement. There are three types or classes of levers, according to where the load and effort are located with respect to the fulcrum. The ratio of the load and effort is called mechanical advantage. Using the right kind of lever in the right way allows a user to lift larger loads with smaller efforts. The brake pedal uses leverage to transfer the effort from the driver's foot to the master cylinder.
Right this moment, there is a mad rush in America. Apple, Amazon, Facebook, dozens more.
Brake systems use hydraulic fluid in a closed system. The hydraulic brake system is governed by physical laws that makes it efficient at transmitting both motion and force. Pascal discovered the scientific laws governing the behavior of liquids under pressure. Pascal's law states that pressure applied anywhere to an enclosed body of fluid is transmitted equally to all parts of the fluid. In other words, 100 pounds per square inch, psi, generated at the master cylinder is the same at each wheel cylinder, as well as anywhere within a static system. Another important distinction to make is that liquids cannot be compressed, whereas air is compressible. Hydraulic pressure represents the force applied to the liquid. Fluid pressure is determined by dividing the input force applied to a piston by the area of the piston. The same pressure applied over different areas can produce different forces, larger and smaller. Cylinders of the same size, when the force is applied to master piston, the slave piston will move the same amount with the same force. By using cylinders of different sizes, forces can be increased or reduced. If the smaller piston is moved, the larger piston will move with more force, but it will move a shorter distance. The ratio of the area of the slave cylinder bore divided by the area of the master cylinder bore determines the hydraulic advantage. Gases are compressible. Pressure applied to air changes its volume and a hydraulic system must be free of air to operate properly. If air is in the system, the air is compressed when the brake pedal is depressed, and the brake fluid does not transmit the force to the wheel brakes. Bleeding brakes is the process of removing air bubbles from the brake system. Each caliper or wheel cylinder is provided with a bleeder screw located behind it, for bleeding brakes. When the screw is loosened, the tape point uncovers the bleeder hole. This permits air to move up around the point, through the cross hole and out the center passageway. When the screw is tightened, the point seals the opening.
Abhiram P. Suresh.
Present, sir.
Abhin.
Present, sir.
Adarsh KK.
Present, sir.
Akshay.
Present, sir.
Alvin Thomas. Amal KP. Amal K. Santosh. Amal M.
Present, sir.
Anandu. Anandu P. ഓൺലൈനിൽ കിടപ്പുണ്ടല്ലോ. ഇല്ല എവിടെ നിന്നും. അനന്തു. അനുരാഗ്.
Present, sir.
ആശ്രയ് കുമാർ.
Present, sir.
അശ്വിൻ. അശ്വിൻ. ഭഗത് വിജയൻ. ദിജിൻ.
Present, sir.
ഫസിയുദ്ദീൻ.
Present.
ജിജോ രാജ്.
Present, sir.
കാർത്തികേയൻ.
Present, sir.
ജിതിൻ സി.
Present, sir.
മൃദുൽ.
Present, sir.
രാഹുൽ. രാഹുൽ പി. സൂരജ് എം.
Present, sir.
സൗരവ് നമ്പ്യാർ.
Present, sir.
ശ്രീരാഗ് സന്തോഷ്.
Present, sir.
വൈശാഖ്. വൈശാഖ് പി.
Present, sir.
വൈഷ്ണവ് സി കെ.
Yes, sir.
വൈഷ്ണവ് പി കെ.
Present, sir.
വസീം. വസീം സി. ഇല്ല. ദിനിൽ ലാൽ. ദിനിൽ ലാൽ. ജിഷ്ണു കെ. ജിഷ്ണു മോഹൻ.
Sir.
ജിഷ്ണു കെ ഉണ്ടോ? Vishnu K.
Vishnu Mohan present.
Nigil Gopal.
Present, sir.
Roshit PK. Vishnu AP.
Present, sir.
Tejas Mohan.
Present, sir.
Akash Prakashan. Akash Prakashan. Abhinav Jain.
Present, sir.
Tejas Mohan ഉണ്ടോ?
Sir, ഉണ്ട് sir.
Abhinav Jain.
Present, sir.
Gogul Prasad.
Sir.
Sachin Sushar.
Present, sir.
Okay.
Sir, Anandu ഉണ്ട്. Sir, Anandu.
Anandu. Okay. Anandu idea.
The brake fluid is a special fluid with special properties. Most are a mixture of glycerin and alcohol called glycol, with additives to give it the characteristics that are needed. Brake fluid is clear or slightly amber in color. Brake fluid is specifically designed to be compatible with its environment of high heat, high pressure, and moving parts. Brake fluids are composed of three main components: solvent, lubricating, and additives. Properties of brake fluid are correct viscosity at all temperatures, very low freezing point, very high boiling point, non-corrosive, compatible with rubber used in brake system, good lubricant, and hygroscopic, absorbs water. Standards for brake fluid have been established by the Department of Transportation, DOT, and the Society of Automotive Engineers, SAE. There are three grades of brake fluid, DOT 3, DOT 4 and DOT 5. Boiling point for both pure fluid, dry, and water contaminated fluid, wet. DOT 3 and DOT 4 are glycol based, most common in use, blend with each other, and are hygroscopic, absorb water. DOT 5 is silicone based, not compatible with glycol based fluid, and is not hygroscopic. Most modern cars have the fluid type printed on the master cylinder filler cap. Most car manufacturers recommend changing the hydraulic brake fluid every 2 years, or 30,000 miles.
Let's be spoon dalna beta. Thank you.
He's right there, bro. Come on, come on, come on, come on. Yes, bro. Come on, bro.
Chemical energy in the battery is converted to electrical energy in the starter, which is converted to mechanical energy in the starter as it cranks the engine. Burning hydrocarbons and oxygen in the engine creates heat energy. Heat energy is converted into kinetic energy as the vehicle is put into motion. During braking, the vehicle is stopped by converting the kinetic energy of the vehicle to heat energy, which is created in the brakes by friction between moving and non-moving surface at each wheel. The converted heat is absorbed by the brake drums and rotors and dissipated to the surrounding air. Friction brake rotor set up during stress testing. Friction is a force that resists the movement of one surface over another. Friction is due to microscopic irregularities in even the smoothest of surfaces. There are two main types of friction: static friction, which is the resistance between non-moving surfaces and is present in parking brakes, and kinetic friction, which is the resistance between moving surfaces and is present in standard brakes. Friction is always measured for pairs of surfaces using what is called a coefficient of friction. A low coefficient of friction for a pair of surfaces means they can move easily over each other. Coefficient of friction varies based on composition of material and condition of the surface. For example, 100 pounds of ice pulled across a concrete floor may require 5 pounds of force to move, and 100 pounds of rubber pulled across a concrete floor may require 45 pounds of force to move. In a brake system, the coefficient of friction varies on the type of lining used, and the condition of the drum or rotor surface. Brake drums and rotors are forced to absorb a significant amount of heat during braking. Brake fade describes a condition where heat is generated at a faster rate than they are capable of dissipating heat into the surrounding air. There are primarily two types of brake fading caused by heat: mechanical fade and lining fade. Mechanical fade occurs when the brake drum overheats and expands away from the brake lining, resulting in increased brake pedal travel. Mechanical fade in drum brakes is reduced by using larger or heavier drums that absorb more heat before they expand too far. Cooling fins are also added to the drums or make them partially of aluminum to help speed heat transfer to the passing air. Mechanical fade is not a problem with disc brakes, because as a brake rotor heats up it expands toward the brake pads rather than away from them. Lining fade affects both drum and disc brakes, and occurs when the friction material overheats to the point where the coefficient of friction drops off. Some heat increases the coefficient of friction, but too much heat can cause it to drop off sharply. When the coefficient of friction drops off, friction is reduced and the brake assembly's ability to convert added heat is reduced. Track width is the measurement between the center lines of the tires when viewed from the front or rear of the vehicle. The track width is important because it determines how much weight is transferred by the mass of the car in cornering. Wheelbase is a measurement of the distance between the centers of the front and rear wheels when viewed from the side. The wheelbase is important because it determines the weight transferred by the mass of the car in acceleration and braking as well as the yaw characteristics in turning. The positions of the components in a vehicle determine how its weight is distributed while it is standing still. Every part of a vehicle has mass, and depending on where that mass is located relative to the tires, it will affect how much weight is on each tire. Static weight distribution is defined by two ratios: a ratio of the total weight on the front rear tires, and a ratio of the total weight on the left right tires. Balanced static weight distribution, where weight is balanced evenly between the front and rear, 50% front and 50% rear. The weight is also balanced evenly between the left and right sides, 50% left and 50% right. In reality, most vehicles never balance their static weight this well because large components and their necessary positions do not allow it. The driver's weight shifts the left-right distribution to 55% left and 45% right. The engine shifts the front-rear distribution to 60% front and 40% rear. Front-wheel drive vehicles have front-rear distribution about 80% front and 20% rear. Rear-wheel drive vehicles have front-rear distribution about 60% front and 40% rear. Weight transfer is caused by three states: acceleration, deceleration, and steering. When the car moves in one of these directions, the car's weight moves in the opposite direction and compresses the suspension in this area. During acceleration, weight shifts from the front onto the rear tires. What weight the front tires lose, the rear tires gain. The opposite of the acceleration weight transfer takes place during deceleration. During braking, the weight shifts from the rear onto the front tires. During cornering, the weight shifts from the inside tires to the outside tires. Let us imagine a car that weighs 1,500 kilograms, with a typical front-wheel drive car's weight distribution of 60% front and 40% rear. We'll assume the car's side-to-side weight distribution is equal. When standing still, the front tires have a load of 450 kilograms, and the rear tires have 300 kilograms each. The inertia of the vehicle during braking transfers force from the rear to the front effectively, decreasing the weight on the rear wheels and increasing the weight applied to the front wheels.
Okay, thank you.